welcome to True Replicas. In this episode, we will rebuild the Crosman 1400. Among die-hard airgunners, the 1400 needs no introduction, but for the rest of us, the Puntmaster 1400 is a 22 caliber multi-pump air rifle made by Crosman from 1968 to 1978 in a few different variations. I bought this one used and had to have it even though it didn't hold air. There are already a lot of great videos out there on the Crosman 1400 disassembly and reassembly. And in the interest of keeping this video to a reasonable length, I'm not going to repeat all that information here. But what I will do is show you some of the techniques that I use in my rebuild that are not shown in these other videos. The first issue I had was removing the check valve from the compression tube. So this is the compression tube, and the check valve is located right here where this locating stud is threaded into the compression tube. So if you remove the locating stud, you'll see the threaded hole right there. Other videos advise you to tap the check valve out of the compression tube with a wooden dowel like this one. I tried doing that with my disassembly and it didn't budge. The valve was just stuck in there from being in one place for 50 plus years. Probably the O-rings around the valve had bonded to the compression tube walls and just made it really stuck. So my next attempt was to spray WD-40 down the compression tube and let it sit overnight. So I came back the next day and tried tapping it out with a wooden dowel, and same result, it was just really stuck. So I went to my third attempt, which was to heat the tube in the vicinity of the valve. There's the valve. I was going to pass a propane flame back and forth and all around the vicinity of the valve to try and heat it and then release it that way. Understand that any hot metal that you can touch with your bare hands will be about 130 degrees F, and for the record, that's that you can touch without burning yourself and damaging your skin. What we're after here is slightly more than what you can touch, which would be about 160 F. So at that temperature, we won't be damaging the metal in the compression tube, and yet it's just high enough so that the tube will expand and then release the valve. Now you're going to want to do this fairly quickly because you don't want to also heat and expand the aluminum or brass valve that's inside the compression tube. So we're going to just demonstrate it here. You're just going to go back and forth, right where the check valve is. Rotate it. Do that for about 30 seconds. And you can take your dowel pin and the valve should just come right out. You want to knock it out through the front. And there it is. And there's your unstuck check valve. Your disassembled 1400 valve assembly will look like this. After removing the check valve, I discovered a show-stopping problem. The threaded hole in the check valve that the locating stud threads into was completely stripped. Now, this is like the corner of the world, since the whole assembly depends on this threaded engagement. I could not find any replacement valves anywhere, so this rebuild was in jeopardy. I'm sure someone out there had a few valves to sell, but I didn't find them. The other thing to consider is that this valve was made from brass, which are better than the replacement aluminum valves. So I went on a crusade to try and rehabilitate this valve. A word of caution cleaning up the locating stud threads. The stud threads were clogged with brass from the stripped check valve. Without thinking it through, I cleaned the threads with a bench grinder wire wheel, which cleaned out the brass but also rounded off the external threads. A better approach would have been to clean the threads with a 1/4 28 thread chaser. Okay, back to the valve repair. The plan is to redrill and retap a new hole 180 degrees away from the old one. You will need a drill press and a good vise to do this, but it's not too difficult. I had a 2-axis translating vise, but a regular vise will do if you're patient. Step 1 is to locate the old hole for both depth and distance from the end face. I conservatively backed off the depth about 10 thousandths of an inch just to make sure I didn't drill too deep and intersect the check valve hole, which would be yet another showstopper. Step 2 is to rotate the valve approximately 180 degrees. Step 3 is to drill a new hole to depth with a 3-gauge bit. The thread is a quarter 28, which is a fine thread, so use the correct size bit, which is a 3-gauge. There's no turning back once the chips start to fly. Without removing the valve from the vise, insert the quarter 28 bottoming tap in the drill press chuck. Apply some oil to the tap and then carefully rotate the chuck clockwise by hand while applying downward pressure to the chuck until it bottoms in the hole. Next, carefully back out the tap as you rotate it in the opposite direction counterclockwise until it clears the hole. Step 5 is to remove the tap from the drill press since we are going to modify it to make a super bottoming tap. Be sure to leave the valve in the vise to maintain position. The threaded hole needs to be threaded all the way down to the bottom, and the standard bottoming tap will not do that. So we are going to transform it into a super bottoming tap. Put the tap in a drill and then grind off about 1/8 of an inch with a bench grinder. Keep the tap cool with water so you don't soften the steel. Remove the tap from the drill and blend out any burrs with a sharpening stone. You're after a square end with sharp full threads that extend to the very end. Step 6 is to reinsert the modified tap into the drill press chuck, apply oil, and recut the threads all the way down to the bottom of the hole. Despite my best efforts with a 2-axis vise, the retapped hole ended up about 20 thousandths of an inch off center. So if you notice that the hole appeared off center, that was not an optical illusion. It was slightly out of tolerance, and the assembly did not fit together. But not to worry, since I was able to recut the tapped hole the second time by rotating it 90 degrees instead of 180. I was a lot more careful lining everything up on the second try, and it worked. Needless to say, your best bet is to measure twice and cut once, and avoid the additional headache of a second try. The next repair was to R&R the link rivet, which on my 1400 was really worn out. I searched high and low for a replacement rivet, and like the check valve, I couldn't find just one for sale, even though I knew someone out there had one. So plan B was to go online, where I found a bag of 50 Crest rivets of identical size and a rivet heading tool like this one on McMaster car. The next step is to carefully drill out the old rivet. And I say carefully because you'll want to drill out the rivet without damaging the linkage material below it. The drill bit will want to grab onto the rivet and spin it, making it impossible to drill out. You can stop the rotation of the rivet by inserting a small piece of rubber tubing like this into the linkage, and then with a little hand pressure, you can apply friction force to the rivet, and that will allow you to drill it out. The last step is to assemble your linkage, bushing, and rivet, and back it up with a steel plate. Then use your rivet heading tool to deform the hollow end of the rivet until it mushrooms over the hole. Pay attention to the orientation of the link arm, since it's not symmetrical. In the assembled condition, you want the radius to face down and away from the compression tube. At least that is how mine was oriented. Also, there is little bushing inside the link, so be careful not to lose that when you remove the old rivet. I encountered yet another show-stopping problem on my 1400 rebuild. a broken exhaust valve. There should be a crimp at the red arrow that locates and retains a seal in the exhaust valve. But on this rebuild, the all-important seal had sheared past the crimp. This is what can happen if the 1400 is overpumped, a blown seal. The exhaust valve is located as shown here and seals off the pressure built up inside the exhaust valve body during pumping. Pulling the trigger allows the exhaust valve to unseat and slide to the right, which allows compressed air to flow through the exhaust valve ring and into the barrel via the small hole. A functioning exhaust valve will be crimped to locate both the seal and seal retainer. My valve was damaged and was missing the crimp, so the seal and retainer had blown off. I could not find a new exhaust valve, but I was able to get my valve repaired by sending it to JG Airguns. You can find their website at the end of this video. The repaired valve was recrimped with a new seal and retainer. Do not try to do this yourself, since crimping requires specialized tooling and you may damage your valve beyond repair. Yet another issue I encountered on this rebuild was a deteriorated plastic barrel spacer. As you can see, the spacer is full of cracks, and so it can no longer do its job of tightly aligning and locating the barrel on top of the compression tube. And a loose barrel equals inaccuracy. Luckily, and thanks to Precision Pellet, I was able to obtain a replacement barrel spacer made from anodized aluminum. You can find the website for this part at the end of this video. Due to too many scratches on my 1400 stock, it needed a finish refresh, and this is the result. I first sanded the white oak stock down to bare wood with 150 grit and then applied a light coat of stain, in my case golden oak, to darken it. After a 24-hour dry for the stain, I applied one coat of my go-to sealant for rifle stocks, which is boiled linseed oil. It's a natural oil made from flaxseed, and the wood readily absorbs it. I did say I like to use boiled linseed oil, which is just raw linseed oil with some solvents added to speed up the drying time. I only applied one coat on this project. Apply the oil with a rag and then come back after 1 hour and wipe off any excess that was not absorbed. If you put too much on, it will literally take weeks to dry, so don't overdo it. The lin in linseed oil was derived from the Latin word linium, which means line or rope. And back in the day, flax was used to make rope and linen cloth. Even linoleum flooring was made from linseed oil. Rags saturated with linseed oil have been known to spontaneously combust due to heat generated during curing. So, to avoid a bad surprise in the middle of the night, don't bury your linseed oil soaked rags in the bottom of your garage trash can. Instead, put them outside to dry, preferably inside an empty metal coffee can and away from any other combustibles. I have never seen this happen myself, but don't invite a fire. Okay, that's it for this project. My rebuilt Crosman 1400 looks and works great. Look for my next episode of True Replicas, where I will do a head-to-head, barrel-to-barrel comparison between the 22 caliber Crosman 1400 and my other rebuilt favorite, the 5mm Sheridan. So until next time, keep it true.